Hey everybody, this is Larry. This is me doing one more additional problem here in June 9th, on June 9th at in North Carolina, Charlotte. And yeah, uh, I've been doing the recent problems, but today let's just do an RNG one. Let's do a random one. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's video. I don't know if I already said it. I don't know, very tired. But yeah, let's get started on today. 2852, sum of remoteness of all cells. You're given a zero index matrix grid of order n by n. Each cell in this matrix has a value grid sub I j, which is either positive number or positive integer or negative one represent a blocked cell. You can move from a non-blocked cell to any non-blocked cell that shares an edge. So up, down, left, right. For any cell I sub j, we represent its remoteness as R sub ij. Okay. If ij is non-blocked, we turn the sum over things. Okay. So I don't know. This example is weird. Okay, there you go. I wanted the actual thing first. Okay, so you have the initial values, and then R sub ij is equal to the sum of the values such that there's no path from non-blocked cell. Say what? For blocked cells, R sub ij. Okay, yeah, that's fine. And then now what? And then we just return the sum of all those. Return the sum of, okay. I mean, this is sorry. I'm trying to process my allergies. Like let me try to drink this liquid real quick, actually. But this is a very straightforward representation of connected components, right? Excuse me. I had a very good breakfast and a very good lunch, and I think I've been just food comaing all day from eating way too much. Here in I ate in South Carolina. I ate a lot, and then I ate a lot in North Carolina. And not gonna lie, there's a Waffle House right outside my hotel, so I'll definitely check that out. Even though it's already 10 o'clock, I'll probably check out like a late night snack situation. But yeah, this is connected components because basically you have things that are going to be mutually blocked from each other because from a non-blocked cell and you cannot get to another non-blocked cell, they're going to just like sum each other, right? But if they're connected, also by the definition of just connectedness, I suppose, it is transitive, right? Meaning if A is connected to B, B is connected to C, then A is connected to C. But also by that virtue, if A is not connected to D, then none of the other things are connected to D. So you basically have islands of components, and then you just kind of figure all that out. Okay, right? So pretty good idea so far. There is some stuff that you have to be a little bit mindful of, a little bit careful of. For example, in this case, I'm trying to highlight this, but it's not working. You have 4 islands, right? A naive approach may be just doing like, okay, let's say we're at the one that's on the top. You may try to sum up all the other islands, and that's fine, but that's going to take possibly all of n times because there could be, in a checkerboard situation just shown, there could be n over 2 islands, right? So, and then if you do that for every island, then that's going to be n squared. No bueno. So what you want to do is just be a little bit careful by calculating the sum of all the R, the sum of everything minus itself, right? So then that will allow you to get what itself is worth, and then you sum up everything all together again to as part of the answer, right? That might be a little bit fast. Definitely feel free to rewind and listen to it again, but we'll go over it in code again, so we'll be okay. So let's get started. Yeah, we're playing with wait, oops. And then what we want to do is yeah, let's do what was it? And we could do it in two ways, right? We can do it with we could do it with oh sorry, three ways. Did I say two? You could do it with union find or disjoint union set, disjoint set union, DSU. I don't know, I'm struggling there. But the other is depth first search or breadth first search. The thing I'm going to do, I don't know. I was going to say if I have like a dice or something and I just do one randomly. But I don't really have a three-sided die. All right, let me just ask Google then, right? So roll a dice between 1 and 3, inclusive. All right. Hang on. I'm gonna roll. Wait, what? I don't know why this like. Okay, give me a second. I'm trying to find the dice. All right. Okay, I think I've got this. Maybe. All right, I'm just gonna put it on the screen so that it's all fair, right? I didn't roll it yet, so nope. There's no D3. I roll a D6. What the? Get rid of that one. What? So now, let's say if it's 1 and 2, we have depth first search. 3 and 4 we have breadth first search, and 5 and 6 we have union find. So okay, let's roll. 1, 2, 3, go. 4. So that's depth first search, right? I think so. All right, so let's do it with depth first search. Connected components should be okay, right? What's R and C? Okay, just the thing with the depth first search is that you have to be a little bit careful. Is sometimes you want to stack size issues and stack depth issues. So, but usually not an issue, but just something to be mindful of just in case. But yeah, so we'll calculate. We'll just call it visit. We have an XY for the components, right? And we have a directions. Directions, we have the 4 directions that we care about. And the way that I set it up is so that is dx dy, which is the delta x delta y, right? And then maybe you just do like up, down, left, right. So up would be negative x, right? That's where the down is positive x. Left is negative y, and yeah, right would be positive, right? And then okay. And then maybe we'll just name them colors or something like this, right? Oops. Something like hang on. None times C for right? So R times C grid of nuns, and then here we'll set up something like yeah, we also need what do we need? We need a total for an island. I call it an island because that's just like a lot of connected component stuff. So for each island we want to, or for each, so we're gonna color the islands one by one, and we want to keep track of the sum of the things, right? So then maybe we can say something like total is equal to so it's a for and yeah, and then now we do something like for J and C. So then if let's just say X and Y, right? So then if the colors of X and Y, so if we haven't colored this yet, is none. But also if it's if grid of XY is not equal to -1, right? Or maybe just greater than 0. So if this is true, then we haven't there's no colors for this one yet. That means we haven't visited yet. So then we can actually we should put a color on this one too. Yeah. And then we can say yeah, visit XY and maybe the length of total. Yeah, and then this will return some stuff. So then we can say, yeah, so then this is the result, and then we can append R, and this would be the same color as that, right? yeah, yeah. And then now we can do something like if colors of xy is not none, then we return 0. That means that we either processed it or it's out of bounds or whatever. I don't know. Well, we already done it. Yeah, and then now otherwise for dx/dy in directions, if I can spell correctly, well, we have to actually set the colors, right? So it's equal to color. We have, let's just say total is equal to 0 because that's the thing that we, it's equal to grid of xy, and then now for each thing we have dx/dy. We have x is equal to nx, right? So then now we want to make sure that this is inside the grid. We also want to make sure that it is also a not blocked one, and colors of x, y, or nx and y is not. And I know that we also check it here, but I don't know, maybe I'm just a little bit overly cautious. Not the case. Then now we can total be added to visit nx and y and the same color, right? And that's pretty much it, and then we return total. So then now total sub I is going to be the sum of everything connected to that island, right? Yeah, and then so then now or total, maybe or total is equal to sum of total, right? And this part is maybe there's a way to do the math. I mean, okay, we'll do it. We'll do it the silly way first, but I think you can actually. Wait, maybe I messed this up. I did mess this up because I only count the number of islands, but what we also need to do is count the number of cells, because each cell has multiple contribution to the end result, right? Because I don't know if there's an answer. Yeah, for example, in this case, right, the top 3 and the top 4 both has 3 as the thing, which is you can see on the upper right thingy, but it counts twice, so we have to count the number of cells here. Yeah, okay, fine. And there are a couple of ways you can do this, I guess, but yeah. Maybe I could just do like count is equal to 1, right? And then now we can let's equal to child total, child count is equal to this, and then total cc, the other way around, count. And now we just return this, and then yeah, and then t for total, c for count, right? Okay, but we do want to do all this. So then now for each cell, or for each color, right? So for C in color, we are going to, so then the width, this one cell is going to be cost of or total minus total sub C, right? Actually, I guess C is, no, this isn't colors. It is in length of total. Yeah, okay. Yeah, or total minus total is going to be the current cell value, right? Let's put cell value is equal to this, and then answer is equal to 0, and then answer is just equal to the cell value times the number of cells, which is count of C, and then that's it. But yeah, all right. Well, int object not iterable. Yeah, I know. Give it a quick submit. Yep, looks Gucci. Yeah, what I was saying is that you can see that this formula, you can actually probably do the summation in a smarter way. Um, but I'm okay. It's fine. I don't have the brain cells today. So what is complexity here, right? Well, we only visit each cell once when it doesn't have a color, right? So this is going to be linear time in the size of the grid, right? For the visit part, including this part. This is just regular connected components, linear size of the grid, which is going to be R times C. Keeping in mind that R times C is the input size, so it's linear in the size of that. How many colors can total be? Well, and also it's all of R times C space because we have this thing. But and at least for this part, how many colors can there be? Well, there can be linear number of colors, right? Which is R times C over 2. Like I said, the checkerboard pattern is one example, right? Yeah, you could round up if you want to do the other checkerboard. But in any case, it's going to be linear, right? So that means that this is also all of R times C in the number of space, and as a result, also time because we iterate through it. And that's pretty much it, really. Yeah, you could probably have written this smaller too, maybe. But yeah. So linear time, linear space, pretty funky, pretty. I don't know. I think this the problem's a little bit weird, but the solution is fine. I don't know. I end up using 2 pages. So here's the first chunk, here's the second chunk, and that's all I have for this one. Let me know what you think. Thanks for watching. Yeah, live from Charlotte, North Carolina. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.